Hello students, welcome to Aptdemy's live class. I hope you are going through our course material in Aptdemy's website. You are finding out the problems what we have provided to you. And as usual, if you have any difficulties in learning or solving the worksheets, please come back to us. And as we are doing, we are arranging some classes, live classes for you, and we're providing the solutions through other channels. Now, there's the information for all of you. Those who are regular students of Aptdemy and those who are thinking of joining Aptdemy, they can attend a live or physical demo class at our Aptdemy's Lake Town branch on 11 June, and there will be demo classes by your faculty members on physics, maths, and chemistry. Some interesting, important topics will be covered on that day during the time span 9:30 to 5 o'clock. Okay. So all the three subjects, physics, maths, chemistry, some important chapters will be covered by your faculty members. So those who are interested, kindly contact us. Details are provided in our Facebook page, YouTube channels. So please contact us, let us know that you are joining, and then I hope you will be enjoyable, rich experience for all of you. Okay. In today's class, let us consider few problems from mechanics. Mostly they are from work for energy. These problems, actually, we have got feedback from our students. So we thought we picked up the problems from the feedbacks received from our students, and I have selected few problems today for discussion in this live class. Okay, let us see what are the problems. This is the first problem. What is that? Let us see. A force F equal to minus kxi plus yj, I cap j cap. These are unit vectors along x and y direction. K is a positive constant, acts on a particle moving in the xy plane. Starting from origin, the particle is taken along positive x-axis to the point A0 and then to the point AA. The total work done by the force on the particle is which one out of these four options? So this is the IIT problem, and it is interesting. Let us try to see what is the solution. So if a particle is acted upon by a force F equal to minus k x I cap plus y j cap. Okay. Now the particle starts from origin. This is origin, and taken along positive x-axis. Starts from origin, is taken along positive x-axis and taken up to the point A0, which is on the x-axis itself. And then this is y-axis. And then from A0 to the point AA. So this is AA point. So first from O to A you can say, then A to B, where B's coordinate is A, like this. Starting from origin, the particle is taken along the positive x-axis to the point A0 and then to the point AA. Okay, like this. Total work done by the force on the particle is how much? That we have to find out. So, total work done is equal to work done in taking the particle from O to A, origin to A, and then work done in taking the particle from A to B. I can write like this, total work done. But what I know is F dot ds. This is the expression for work. Force vector dot displacement vector. So total work done, if I call this dW, then total work done W when the particle is taken from a point 1 to point 2 is how much? Integration of F dot ds from point 1 to point 2. Okay. So evaluate the integral under the limit if integral F dot ds from point 1 to point 2. So if I apply this, so the particle is taken along x direction first. So it is F dot dx. It is moved along positive x-axis and integrated from x equal to 0 to x equal to a. This is most authentic standard expression for W0 from this. So what is dx vector is actually I can write is I cap dx. Dx vector is directed along x direction. Okay, so f dot dx I can write f is this much. So f dot dx is only minus kx dx. Okay, so integral x equal to 0 to a minus kx dx. This is simple. F dot dx is kx dx because I dot j is 0. As I dot j is 0 and I dot I is 1. I and j are the unit vectors along x-axis and y-axis respectively. So it is how much? It is minus k a square by 2 because minus k x square by 2 in the limit upper limit a lower limit 0. So it is actually minus k x square by 2. You can write 0 to a. So it is minus k square by 2. So this is W0. Now what is WAB? So let me remove this. So WAB is how much? This much. This part of the W, that is W A to B, is here the movement is along y direction because this is A to A0 to A, that means you have to move along a line which is parallel to y-axis. So displacement vector is totally directed along j direction. Therefore, in this case, change of variable is from y equal to 0 to y equal to a because x remains constant along the line AB. So it is variation is on y from y equal to 0 to y equal to a. And here displacement is along y direction. I call it dy. And dy elementary displacement is actually j dy. So in this case, since f is minus kxi minus kyj, so it is actually y equal to 0 to a integral minus ky dy minus ky dy. So it is how much? It is actually minus k a square by 2. So W 0 is minus k square by 2 and WAB is minus k square by 2. Therefore, W which is equal to W0 plus WAB is equal to minus k square by 2 minus k square by 2 minus k square by 2. So it is minus k square. Okay, so this is the work and therefore this is the right answer. This is k square. So answer is C. C is the right answer. Okay, so this is right answer C. Answer is minus k square by 2. All right. I hope it is clear. Simple work is actually d work dw is equal to f dot ds, and from initial point s1 to final point s2, and evaluate these integrals. Here total work is W0 plus WAB, and separately work from W0 and WAB, and from that you could find the total work is minus k square, which is there in C. C is the right answer. I hope it is clear. All right. Next problem. Let me take this color. A particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration AC is varying with time as AC equal to k square or t square, where k is a constant. The power delivered to the particle by the force acting on it is which one out of the four options? So a particle is executing a circular motion like this along this circle, say for example, and it is moving in a circle of constant radius r. Okay, but the centripetal force acting on it, let us remove this arrow from here. This is the center, and centripetal force at any position it is acting towards the center of the circle. But here the peculiarity of this problem is the centripetal force is function of time, because centripetal acceleration AC is equal to k square r t square. Okay, which is function of time basically. Okay, so let us take this. AC is k square r t square. But in case of circular motion at any point, the centripetal acceleration is in this direction and force is also in this direction. So force is mass into AC is equal to m k square r t square. K square r t square. Now, if the instantaneous velocity of the particle is v, then at this point, then we know m v square r is the centripetal force. So I should equate this with this m k square r t square. So we can write v square equal to m cancel from each other. So v square equal to k square r square t square. So the instantaneous velocity of the particle is v square, and which is k square r square t square. Now here, unlike normal uniform circular motion, here the velocity is function of time. With increasing time, v is also increasing. V is actually k r t. So velocity is not uniform in this case as per the problem, and velocity is increasing in time. As the velocity of the particle is increasing by executing this motion along the circle like this, so its kinetic energy is also increasing. So kinetic energy is half mv square if I write. So it is how much? It is half m v square is k square r square t square. All right. Now the energy, instantaneous kinetic energy, it is actually kinetic energy. We are considering only kinetic energy. So instantaneous energy of the particle is half m k square r square t square. Now, with passage of time, the energy is gained by the particle, and the rate of change of energy because of the force, which is time dependent force or acceleration, which is a square k square r t square, the energy of the particle executing circular motion, it is increasing, and the rate of increase of energy is actually d dt, which is nothing but the power delivered to the particle by the force acting on it. Because of the force, its velocity is continuously increasing, and the rate of increase of energy is d dt, which is nothing but the power. So we have found the expression for E. So it is how much? d dt is actually half m k square r square into 2t. So it is m k square r square t. m k square r square t. So power delivered to the particle by this force or is actually m k square r square t. So the right answer is this one. C, it's not C, B. It is not C, it is B. Okay, so this is the right answer. M k square r square t. Okay, so power is m k square r square t. So there is a peculiar force which is acting on the particle, and because of the force actually the centripetal acceleration is k square r t square. The particle of mass m is moving in a circular path of constant radius r, such that its centripetal acceleration is varying with time. So centripetal acceleration is varying in time means the centripetal force is also varying in time, because F equal to A m into AC. So we have written like this: m into AC, m k square r t square. Okay, and then we calculated v square, equating F as m v square by r, and then from this v square you have used in computing the kinetic energy of the particle, which is actually half mv square, and then differentiated E with respect to time, that is the power. So P equal to m k square r square t is the correct answer. This is in B. So B is the correct answer. I hope it is clear. Okay. Next problem. What is the problem? Let us see. A stone tied to a string of length A is held in a vertical circle with the other end of the string at the center. At a certain instant of time, the stone is at the lowest position and has a speed u. The magnitude of change of its velocity as it reaches a position where the string is horizontal is which one of the four options? A, B, C, D. So the particle is moving along a vertical circle. This is the plane of the smart board is the plane where the particle is executing, which is a vertical plane. Okay. Now, when it is at its lowest position, so this is the center of the circle, and its length is L. And when it is at its lowest position, the velocity or speed of the particle is u. Speed of the particle is u, and if I consider a xy coordinate system sort of thing, this is x direction, this is y direction. So at this position, velocity of the particle is actually u I cap, I can say u I cap, because it is in the x direction. Okay, I cap is the unit vector on x direction. Now when the string is horizontal, the magnitude of the change of its velocity is how much that is to be calculated. Now when it is the string is horizontal, its velocity, I take this is v. Okay, let it be v. So if I call this point as q, then vq, velocity of the particle when it is at q, is actually v, and since it is tangential, so it is v j cap. Okay, now this height u to p, this is actually L, is it not? This is L height above. PQ is L height above Q. P. If I take this as zero potential energy, this particular level, I am taking its potential energy is zero. This is the reference plane. This particular horizontal line, this is the reference line where we assume the potential energy to be zero. So, what is the total energy of the particle at P? Is half m u square. And potential energy I have taken as zero. Okay. And TQ, the total energy of the total mechanical energy of the particle at position Q is half m v square plus m v l. So since Q is L height above P, so gain in potential energy is mgl. So assuming this as zero potential level, zero potential energy level, here the potential energy is mgl. If I take here potential energy is non-zero, if I take something, say some constant alpha, then here it is alpha plus mgl. So let us take alpha to be zero, because we are just bothered about the change in potential energy, and change in potential energy is mgl. So by conservation of energy, P should be equal to TQ. Okay. Now that means half mu square is equal to half mv square plus mgl. So v square is u square minus 2gl. Okay, so the magnitude of the velocity at the position q, if it is v, then v square is u square minus 2gl. Now what is the question? The magnitude of the change of its velocity as it reaches a position where the string is horizontal. That means I have to find the vector VQ minus VP. This is nothing but the change of its velocity. What is the magnitude of this? That you have to find out. So VQ minus VP is how much? VQ is V J cap minus VP is Q I cap. And what is the magnitude of this? So it is Vj minus Ui, or you can say it is mod of minus Ui plus Vj. So it is square root of minus U whole square plus V square. Okay, so it is square root of U square plus V square. Now, what is U square plus V square? V square is actually, if I just write this thing, Vp, Vq minus Vp, magnitude is nothing but square root of U square plus V square, and use this V square. So it is actually V square is U square minus 2gl. So it is 2U square minus 2gl. Okay, so it is square root of 2U square minus gl. 2U square minus gl. So mod VQ minus mod VP equal to 2U square minus gl. So 2U square minus gl, it is appearing in this option D. Therefore, answer D is the right option. So this is correct answer. Square root of 2U square minus gl. Okay. I hope this is clear. Calculation. Simple thing that at this position the velocity is tangential to the circle and it is basically horizontal direction. It is the x direction. So velocity Vp is U I cap, and at this position when the stream is horizontal, the velocity is tangential to the circle, and therefore Vq I can write it is Vj. If I assume that V is the magnitude of the velocity at q. So Vp is Ui and Vq is Vj. So Vq minus Vp is actually Vj minus Ui. Now, assuming the potential energy of the particle at this point alpha or 0, the potential energy at this point will be alpha plus mgl, or if you take 0, it is only mgl. Then total energy of the particle at P must be equal to total energy of the particle, mechanical energy of the particle at Q. So from that, we have written half mu square equal to half mv square plus mgl. From that, we found the value of v square. V square is u square minus 2gl, and magnitude of the change in velocity is square root of u square plus v square. So it is actually 2u square minus gl. So this is the correct answer. I hope this is clear. Okay. Another problem on same chapter, work for energy. Let us see what is that. A body is moved along a straight line by a machine delivering constant power. The distance moved by the body in time t is proportional to which of the four options? A, B, C. So, if body is moved along a straight line, this is a straight line, and body is moved along the straight line, I consider this straight line as x-axis. And the body starts from origin, say for example, at time t equal to 0, body starts its motion from x equal to 0, and the motion is executed by a machine which delivers constant power. Now, at any moment t, the particle is at x, whose coordinate is x. That means it is x distance away from the origin, and at this moment its velocity will be v. Okay, so its energy is half mv square. Forget about the potentiality because there is no change in potential if it is moving along x-axis. Okay, we are just concentrating on kinetic energy because of the machine, since it is delivering constant power, its velocity is changing and it is moving along this x-axis. So dV dt is the power delivered by the machine because of the machine it is gaining energy, and if we want to calculate the power delivered by the machine, it is nothing but P equal to dV dt equal to mv dV dt. Okay, so since this is constant, power delivered by the machine is constant, so I can write mv dV dt to be constant k1. K1 is a constant. Or I can write v dV equal to some other constant k2 dt, but k2 is actually k1 by L. So if I integrate both sides, then I get v square by 2 equal to k2 t plus another integration constant k3. Now the particle starts from rest. If I assume, that means when the machine starts operating, initially the particle was at x equal to 0, t equal to 0, and then because of the action of machine, it is moving. So at t equal to 0, you can safely assume v is equal to 0. That means at the point of starting, initially particle is a state, is at rest, and the body is moved along the straight line by a machine delivering constant power. So machine starts drawing the particle along its direction at t equal to 0, where the particle was at rest. So at t equal to 0, if I assume v equal to 0, then v0 is equal to k2 into 0 plus k3. So k3 I can safely assume to be 0. So v square is equal to 2k2 t. So 2k2 I can take it as another constant. So 2kt, k4t you can write. So v is actually some constant k5 square root of t. But v is what? V is the instantaneous velocity of the particle at time t. So it is nothing but dx dt. So dx dt is k5 root over t. So dx is actually k5 root over t dt. So x is, if I integrate this, integration of dx is actually k5 t to the power 3 by 2 divided by 3 by 2 plus another constant k6, integration constant. Is it okay? To the power half, you know that t to t dt, t to the power n dt is actually t to the power n plus 1 by n plus 1. So here it is t to the power, here it is actually v is k5 root over t. So t to the power half plus 1 t to the power 3 by 2 divided by 3 to the power 3 by 2. So x is this one, x is equal to 2k5 by 3 t to the power 3 by 2 plus K6. K6. But x equal to 0 at t equal to 0. It's a basic assumption we have taken. So if I plug in x equal to 0 at t equal to 0, then we get K6 equal to 0. So the expression x becomes x is some constant multiplied by some constant k, which is 2k5 by 3 t to the power 3 by 2. So x, the displacement of the particle or the distance moved by the particle is proportional to t to the power 3 by 2. So x, the distance moved by the particle, is proportional to t to the power 3 by 2. And therefore, C is the right answer. So C is the right answer. X is proportional to t to the power 3 by 2. So answer C is correct, as x is proportional to t to the power 3 by 2. Okay, so I hope you have understood the analysis. So we have considered few 4 IIT problems on work for energy. I hope you have followed the way that methodology used in solving the problems. If you can understand this, then I think it will be beneficial for you in solving such problems in future. So just work out our problem sheets, come back to us if you have any difficulty, and we will have more such interactions in near future. Thank you very much. And once again, I want to remind the people, the students who are interested to enroll them in Aptdemy's regular program, they can avail the facility of joining a demo class being arranged on 11 June next at 9:30 morning at our Aptdemy's Lake Town branch classroom. Thank you very much. Thank you. You